All right, folks, these are going to be the notes for section 6.2 to 6.5, and we're going to be kind of doing the whole chapter here in one video and in pretty much, a few different assignments here for 4 different assignments, and we're going to do it all this week. And it's not so bad. Okay, what we're going to be doing is finding surface area. So we're going to have three-dimensional shapes. We'll have some of these things called prisms. And a prism, a common example of a prism, let me scoot up, here's a box. Okay, we're going to do cylinders, which are like cans and cones, and also pyramids. But the idea is the same for all of them. So the surface area of a three-dimensional shape, you could think of it for a box. If you have a three-dimensional box, the surface area is how much cardboard you need to make the box. Okay, not the space inside the box. That's called the volume, and we're going to get there in a minute. But the surface area is how much material do I need to build this three-dimensional shape. So forgive my not so great artistic skills here, but there's some good pictures in the book, and I know that reading a math book is not generally one's idea of fun. However, I highly recommend taking a look at the pictures leading up to these assignments in the math book just to get an idea of where some of these formulas come from and what exactly it is we're figuring out. Okay, so we're going to start with prisms. Okay, now there's a couple vocabulary words I want to go over here with prisms, and they are bases and faces. Okay, now the bases, that word I find misleading when we talk about prisms because usually when we talk about a base, we're talking about something on the bottom. Okay, but that's not the case with a prism. The base does not have to be on the bottom. Okay, what a base is for a prism, they are the sides or they are the shapes that are exactly the same and parallel to each other, so they never intersect. So in this prism here, these green triangles are the same size and they never touch each other. So the base of this prism is the green triangle. Okay, the other sides, if you will, like this rectangle here, there's a rectangle in the back and one on the bottom. Those are called the faces. So this prism is made up of two green triangle bases and then one, two, three rectangle faces. Okay, we don't talk about the sides of a three-dimensional shape, we call them faces instead. Two-dimensional shapes have sides. Three-dimensional prisms like this have faces. So really to find the surface area of a prism, we're going to find the area of each face and then we're going to add them all together. So in this example, we're going to find the area of the two triangles and then we're going to find the area of these three rectangles. There's this one here, which is 8 by 5. There's one on the bottom, which is 3 by 8. Those are the dimensions. And there's one in the back. It's really hard to tell here, I know, but it's 4 by 8. Again, the pictures in the book are far better than anything I can draw, and hopefully they won't be quite so confusing once you take a look at them. Okay, so once again, we need to find the area of the two triangles and the area of the three rectangles, and then we add them all up. Okay, so let's take a look at that here. So the green triangles, the area of the green triangle is base times height divided by 2. Okay, so there's one green triangle. Here's the other one. The dimensions are the same, 3 by 4, so it's 3 times 4 divided by 2. Okay, and then I'm going to do the bottom rectangle here. It's 3 by 8, so that's 3 times 8. And then I have this slanted rectangle here on this side, and that's 8 by 5, so that's 8 times 5. And then I have the rectangle on the back here, and that's 4 by 8, so that's 4 times 8. That's how we find the area of that rectangle. So again, here's the area of the two triangles, base times height divided by 2, and then here's the area of the three different rectangles. We're just doing length times width, length times width, length times width for each of those three different rectangles. And then we just, do some multiplication and division a little bit here, and then multiplication there, and add everything together. So 3 times 4 divided by 2 is 6. Here's another 6 from that one. 3 times 8 is 24. 8 times 5 is 40, and 4 times 8 is 32. 6 plus 6 plus 24 plus 40 plus 32 is 108. Okay, so You can definitely use a calculator on this assignment, by the way. So again, you're just going to find the area of all of the faces plus the two bases in this case and add them up. Okay, so that's a prism. Because the bases are triangles, this would be called a triangular prism. Okay, the prism you're most familiar with is just a good old box or a rectangular prism. And there's a little formula for that that you're welcome to use. Sometimes I don't, I just think about it like I did there and find the area of all the rectangles and add them up. But here's the formula. So SA on my notes here is going to be surface area. So again, the surface area of this box would be how much cardboard it would take to build this box. Okay, so you could think of the formula. So there's two rectangles. The rectangle on the bottom and the top are the same size. They're both 5 by 6, 5 by 6. Okay, so there's two of those. There's a left and a right, and those rectangles are the same size. In this case, they're both 6 by 4. And then there's a front and a back, and the dimensions of those rectangles are 5 by 4. Okay, so we can use this formula. So I'm going to call 5 the length and 6 the width and 4 the height. Okay, so 2 times length times width. So 2 times 5 times 6. Again, the 2 comes from the fact that there's two rectangles, the top and the bottom, that are the same. Okay, 2 times length times height. So that's going to be length I said was 5, the height was 4. That'll give us the areas of the front and the back. So 2 times 5 times 4. And then we got the right and the left rectangles. Those are 6 by 4. So 2 times 6 times 4. Just make sure you get all the rectangles when you're working this out. And you'll notice here 5, 6, and 4, I've got two of those numbers in each set of parentheses. And then we just multiply them and add them and work it out. Okay, so again, take a look at the book. They've got some nice pictures and formulas for these two. Okay, so 5 times 6 is 30, 5 times 4 is 20, 6 times 4 is 24. I'm going to double those and get 60, 40, and 48. And then add all those together to get 148 square centimeters. So again, remember we're doing area, so our units are squared. Okay? So that's how prisms work. This is how 6.2 is going to be. We're going to find the areas of all the faces and add them up. For a box or a rectangular prism, you've got a nice little formula here if you want. But for a triangular prism like this one, there's even some trapezoidal prisms on your assignment. Those ones we don't really have a formula for. We're just going to find the area of the bases. They're both the same. Okay, we got two of them in this case. And then we're going to find the area of the faces and then add them all up together to find the total surface area. Okay, there's the first one. There's prisms. Okay, now we're going to move on to the next one. Those are cylinders. Okay, cylinder's just a can. If you want to see where the formula comes from, I highly recommend you take a look at page 264. I'm not going to get into that right now to save us a little bit of time in this video. Okay, so a cylinder is two circles. Okay, the circles have a radius, and we worked on finding the area of circles last week. The area formula is pi r squared. And the cylinders have a height. This cylinder is 8 inches tall. Okay, so here's the formula for surface area of a cylinder. Again, these are all in the book. So 2 pi r squared, that gives us both circles. And then this lateral area, or this sort of side area around here, is given by 2 pi r times the height. Okay? So I wrote it out here a little bit for you to make it a little easy to calculate if you have kind of a simple calculator like one on a phone. So 2 times 3.14 times r plus 2 times 3.14 times r times the height. And again, we'll use 3.14 for pi. Okay, so let's look at this example here. So here's the formula with the numbers plugged in. So 2 times 3.14 times the radius, again the radius was 5, plus 2 times 3.14, those just come with the formula, those don't change, those will be the same every time we do it, times the radius, times 5, times the height, times 8. Okay, again, calculator, just crunch the numbers in there. So if you work this part out, you get 157. If you work this part out, you get 251.2, and then you add those together to get your overall surface area, so 408.2. Okay? So again, surface area for a cylinder would be, if you think of like a can, it would be how much aluminum or how much material do we need to actually build the can. And so in this case, we need 408.2 square inches of material to build a cylinder this size. The space inside the cylinder we're going to do next week, that's called volume. Okay, so again, here's your formula for cylinders right there. For prisms, we didn't really have a formula so much because the prisms can change depending on what shape the base is, but for a cylinder, the formula is always the same. Okay, the next one is a pyramid. And pyramids are kind of like prisms. They don't really have a good formula, so we're just going to kind of work through them. Okay, again, pardon my sort of not so good artistic skills here, but all these pyramids are going to be fairly simple. The bases are all going to be either squares or triangles. So this pyramid has a square base and then 1, 2, 3, 4 triangles, including the one in the back that's hard to see. So we're going to find the area of the square base, and then we're going to find the area of those 4 triangles and add them up. Okay, so the base is a square, so the area of the square is just 8. It's 8 on this side too, 8 centimeters, so it's just 8 by 8, or 8 times 8. And now we have 4 triangles, they're all the same size, so that's where this 4 comes from. And the triangle area is the base, 8, times the height of the triangle, which is 10, divided by 2. Okay, so 8 times 8 is 64. 8 times 10, is 80, divided by 2 is 40. Again, I'm multiplying that by 4 because there are 4 triangles, and I get 160 plus 64, or 224 square centimeters. Again, so no real good formula here. You just have to find all the areas of the bottom and then the triangles that make up the sides or the faces, and then add them all up. Okay, I know this is kind of a lot today, but these are all of the formulas and notes that you'll need to do these 4 assignments: 6.2, 6.3, 6.4, and 6.5. Okay, there's the pyramid. So again, if you get stuck, you might have to go back and fast forward through the video a little bit to get to the one you're stuck on to get a little bit of help. And again, if you get stuck anywhere and the video's not helping, make sure and send me an email. Okay, here's the next one. And that's the last one. It's a cone. Okay, now the cone has a new variable for us, and we use like a cursive L for that one. And I think that's just because a regular L looks like a 1. So we use kind of a cursive L, and we call that the slant height. And that would be this distance right here of this slanted part of the cone. It's not how tall the cone is, it's how long this slanted piece is. And the formula for a cone is pretty easy. It's pretty simple. We got pi r squared, which hopefully you'll recognize as an area of the circle, and that's the base here, this circle on the bottom. And then we have pi times r times this slant height, L. And it'll be pretty obvious in your problems what L is when you see in the book for section 6.5. And that'll give us the rest of the area for the cone part, if you will, this pointy part up on top. Okay, again, I wrote it out here for you. So 3.14 times r plus 3.14 times r times the L. Okay, here's one. This is exactly how it's going to look in your assignment. You'll be given a radius, so it's 3 inches, and a slant height, which is 7 inches, and that's all you need to figure it out. So surface area equals 3.14 times the radius plus 3.14 times the radius times the slant height. Okay, we'll work it out. This part is 28.26. When you do that, again, please use your calculator. If you want to do it by hand, you're welcome to, but you don't need to. And then here's the second part worked out. We get 65.94. When I add those up, I get 94.2 square inches. Again, please don't forget your units. For area, it's square, whatever's in the problem. So here it's inches, so there it's square inches. All right, I know that was a lot today. There's a lot of different things. So please, in addition to this video, I highly recommend you flipping through the book a few pages before the assignment to take a look at how they do some of their examples, and I think that'll be really helpful. So again, if you have any questions at all, please don't hesitate to let me know. Thank you.